The last two steps of the machine learning approach involve testing, training, and optimizing the model. Only supervised learning models can be trained because all the right features and labels or responses are already known. In unsupervised learning, the machine algorithm looks for similarities based only on statistical properties. There are two approaches to train the supervised learning model. The first approach is to use two separate datasets, one to train the model and the other to test it. The second approach is to split a single dataset into two parts, a training set and a testing set. Data analysts prefer the split approach because the algorithm uses the same set of data points for training and testing, and they can change from one iteration to the other. The test set usually makes up about 20 to 40% of the original dataset. The split approach gives greater accuracy when it comes to predicting the unknowns. To better understand how the split approach works, let's go back to the same records belonging to the XYZ firm. Looking at the records, you can see that it contains continuous data. Hence, it requires the regression algorithm under the supervised learning model. Your next step is to find the attributes which affect the outcome. Since employee ID does not affect the outcome, you can drop it from the set. Use 5 of the records for training and the remaining 3 for testing. This would split the dataset into 37.5% test data and 62.5% training data. The response is also split into testing and training sets. This whole approach helps achieve greater accuracy for response predictions. While designing the supervised learning model, consider the following. Response and the features which directly affect the outcome feed the machine learning algorithm and model directly. Fine-tune the parameters of the model based on the training and testing results to optimize its performance and accuracy. This will help you to scale up the model easily. Generalization means predicting the response. Strive for a model which can predict consistently. Scikit is a powerful and modern machine learning Python library. It's a great tool for fully and semi-automated advanced data analysis and information extraction. There are a lot of reasons why Sklearn is a preferred machine learning tool. It has efficient tools to identify and organize problems, such as whether it fits supervised or unsupervised learning model. It contains many free and open datasets. It has a rich set of built-in libraries for learning and predicting. It provides model support for every problem type. It also has built-in functions, such as Pickle, for model persistence. It's supported by a huge open-source community and vendor base. Sklearn really helps data scientists organize their work through its problem-solution approach. This involves choosing the model and machine algorithm based on the dataset type, using the estimator object, which represents the model in Sklearn, by importing the class and instantiating it, fitting the data into the model to train and test it, using the predict method to forecast the response of unseen or new dataset, tuning the model through multiple iterations and result observations, and striving for accuracy using built-in methods that support the predictive model. While working with a Sklearn dataset or loading your own data to Sklearn, always consider these 4 points. Create separate objects for feature and response. Ensure that features and response have only numeric values. Features and response should be in the form of a NumPy ND array. Since features and response would be in the form of arrays, they would have shapes and sizes. Features are always mapped as X, and response is mapped as Y. Linear regression is the most basic and widely used technique to predict a value of an attribute. It's pretty easy to use as the model doesn't require a lot of tuning. It also runs very fast, which makes it more time efficient. The first equation that you see here is a simple linear equation from linear algebra. The linear regression formula is derived from it, where y is the response and x is the input feature. Beta 0 is the intercept of the line, which equals the value of the response variable when the input feature or predictor is 0. Beta 1 is the coefficient of x. It's also called the slope parameter. It corresponds to the change in response variable given a 1-unit change in the predictor variable. Sklearn has a built-in linear regression model, and we'll be using that for linear regression machine learning. The variable u, called the residual value, comprises other factors which affect the prediction but are not included in the model. The regression line, or the least square line, is the line of best fit. Beta 1 is the slope of the line. Beta 0 is the value of y when x is equal to 0. Residual value equals the difference between the actual value and the predicted value of y, which means that it equals the distance between a data point and the least square line. The variable y bar indicates that the slope of the regression line is 0, and the intercept is the sample mean of the response variable. SSR, or the regression of the sum of squares, indicates the difference between the regression line and the mean of the response variable. The variable is explained by the model. SSE, or the error of sum of squares, indicates the difference between the observed value and the regression line. This is the case where the amount of variability is unexplained by the model. So the smaller the value of SSR or SSE, the more accurate the prediction will be, which would make the model the best fit. Let's see how linear regression algorithm works in Sklearn. Linear regression, a Sklearn class, has to be instantiated by creating an object, also called an estimator. If the Boolean variable fit_intercept is true, it calculates the intercept of the model. When the Boolean variable normalize is true, it normalizes the regression variable before performing the regression operation. If copy x is true, then the regression variable is copied, else it will be overwritten and the default value is held true. InJobs specifies the number of jobs that are to be computed in parallel. Sklearn has many built-in datasets. You can use them to learn how to create and train different learning models. So it's important that before you look at those models, you learn how to load those datasets. Let's start by importing the required pandas and NumPy libraries. Then, from sklearn.datasets, you can import any datasets of your choice. To select a dataset, start typing load. As you type it, if you press Tab on your keyboard, a drop-down list with the names of all the built-in datasets will appear. For this demo, I've selected the Boston dataset. Create an object to instantiate the dataset. You can use the built-in describe function to view the dataset's details, such as the number of observations or instances, attributes, and other properties. Use the built-in feature names function to view and print the features of the dataset.